Okay, so we should be live again. Um, Unfortunately, I can't see YouTube yet. I just started up OBS just so people wouldn't think that the stream was totally dead. Yeah, that was really weird. I couldn't even reboot. I had to wait for a stop process, and it just ran out of time, and something got killed in the end, like hard. Hopefully I haven't like corrupted any data. So just signing into YouTube now, and I'm gonna check if the stream is still going. And then we'll just jump back where we started. Okay, so it looks to me like this is sort of starting new streams up, which isn't exactly ideal. It's not really what I wanted to happen, but whatever. I'll go back and edit them. So we're just gonna dive straight back into it. So I'm pretty sure I can remember what that eLisp was. So it was info, the intro, top. What happens if I get rid of that top? Okay, don't know. Let's get back to where we were before. Okay. And I'm gonna open up the scratch buffer, and also I'm gonna start a notes file. Okay. And I just spilt a bunch of V down my front. So that's nice. V, the energy drink. And for some reason that cam is very, very full. Okay. How do I scroll the other buffer? I know there was a shortcut for that. Was it Alt-Shift-V? No. Control-Shift-V? No. Let me look it up since I have to have Firefox open anyway. Scroll other buffer. Emacs. It's not really a command I use typically. Control Meta Shift V. That's elaborate. What about Control Meta V? Control Meta Shift V. Control Meta Shift V. No, that doesn't do anything. Let's check the Emacs manual. Let's just try calling. I think the function is scroll other window. You can run the command. What did it say? Can run the command scroll other window with meta control meta v. Okay. Oh, I see. Okay, so I don't need to scroll this. That's using some other Control H space info scroll up. Space runs the command info scroll up, which is an interactive compiled list function. It is bound to space. Info scroll up, scroll one screenful forward. In info, considering all nodes as one sequence. Once you scroll far enough in a node that its menu appears on the screen, but after point, the next scroll moves into its first subnode, unless info scroll prefers subnodes is nil. I'm gonna put on a jacket. Okay. Yeah, okay. So can I execute that from a different what was it again? Oops, I executed that in the wrong. Oops. The wrong buffer. Info scroll up. Okay. So info scroll weird. Up. No match. Oh, is it case sensitive? Is that actually info scroll up? Yeah, it is. Okay. Weird. And then info scroll. Oh, see, info scroll down. Okay, and then let's see if I can execute that in the other window. Info scroll up. Yeah, I can. Okay. Yeah, cool. Info scroll down. That's weird. It doesn't behave the way I would think it would. It doesn't matter, it's not a big deal. So this is notes. I'm gonna open up the scratch buffer here. Okay, Lisp, a list looks like this. A quote, rose, violet, daisy, buttercup. Okay. This list is preceded by a single apostrophe. It could just as well be written as follows, which looks more like the kind of list you are likely to be familiar with. So then it has a vertically stacked one. Okay. The elements of this list are the names of the 4 different flowers, separated from each other by white space and surrounded by parentheses like flowers in a field with a stone wall around them. How poetic. Lists inside of lists. Lists can also have numbers in them, as in the list +2, 2. This list has a plus sign followed by 2 2s, each separated by white space. In Lisp, Both data and programs are represented the same way. That is, they are both lists of words, numbers, or other lists, separated by white space and surrounded by parentheses. Very weird. Since a program looks like data, one program may easily surface data for another. This is a very powerful feature of Lisp. Incidentally, these two parenthetical remarks are not Lisp lists because they contain semicolon and period as punctuation marks. Oh, I get what he's saying. Ha ha ha. Here is another list, this time with a list inside of it. This list has a list inside of it. Yeah, okay. I wonder if I can make this bigger, because you guys are probably not able to see it. So I'm just googling zoom in info mode to try and find out how I can zoom it in a little bit, because there's a lot of white space anyway. Oh, okay. So I have to do Control X first. Okay, that's a bit much. Alright, so lists can also have numbers in them. As in this list, blah blah blah. Yep. That's weird that doesn't change, but okay. In Lisp, both data and programs are represented the same way. That is, they are both lists of words, numbers, or other lists, separated by white space and surrounded by parentheses. I've already read this. The components of this list are the words this list has and a list inside of it. The interior list is made up of the words a list inside of it. Okay. Lisp atoms. In Lisp, what we have been calling words are called atoms. This term comes from the historical meaning of the word atom, which means indivisible. As far as Lisp is concerned, the words we have been using in the list cannot be divided into any smaller parts and still mean the same thing as part of a program. Likewise with numbers and single character symbols like plus. On the other hand, unlike an ancient atom, a list can be split into parts. See char, cadr, and const fundamental functions. In a list, atoms are represented from each other are separated from each other by white space. They can be right next to a parentheses. Technically speaking, a list in Lisp consists of parentheses surrounding atoms separated by white space, or surrounding other lists, or surrounding both atoms and other lists. Okay. A list can have just one atom in it, or have nothing in it at all. A list with nothing in it looks like this, bracket bracket, and is called the empty list. Unlike anything else, an empty list is considered both an atom and a list at the same time. So it's not. So a list inside of a list is not considered an atom. Maybe. The printed representation of both atoms and lists are called symbolic expressions, or more concisely, S expressions. Okay. So I've heard this term S expressions before. So the printed representations of both atoms and lists are called symbolic expressions, or more concisely S expressions. The word expression by itself can refer to either the printed representation or to the atom or list as it is held internally in the computer. Often people use the term expression indiscriminately. Also in many texts, the word form is used as a synonym for expression. Okay. Incidentally, the atoms that make up our universe were named such when they were thought to be indivisible, but it has been found that physical atoms are not indivisible. Parts can split off of an atom, or it can fission into two parts of roughly equal size. Physical atoms were named prematurely, before their truer nature was found. In Lisp, certain kinds of atoms, such as an array, can be separated into parts, but the mechanism for doing so is different from the mechanism for splitting a list. As far as list operations are concerned, the atoms of a list are unsplittable. Okay. As in English, the meanings of the component letters of a Lisp atom are different from the meaning the letters make as a word. For example, the word for the South American sloth, the I, is completely different from the two words A and E. There are many kinds of atom in nature, but only a few in Lisp. For example, numbers such as 37, 511, or 1729, and symbols such as plus, foo, or forward line. The words we have listed in the examples above are all symbols. In everyday Lisp conversation, the word atom is not often used because programmers usually try to be more specific about what kind of atom they are dealing with. Lisp programming is mostly about symbols and sometimes numbers within lists. Incidentally, the preceding three-word parenthetical remark is a proper list in Lisp. So by that he means and sometimes numbers. Since it consists of atoms, which in this case are symbols, separated by white space and enclosed by parentheses, without any non-Lisp punctuation. Text between double quote marks, even sentences or paragraphs, is also an atom. Here is an example. This list includes text between quotation marks. In Lisp, all of the quoted text, including the punctuation mark and the blank lines, is a single atom. That makes perfect sense. This kind of atom is called a string, for string of characters, and is the sort of thing that is used for messages that a computer can print for a human to read. Strings are a different kind of atom than numbers or symbols and are used differently. Alright. White space in lists. The amount of white space in a list does not matter from the point of view of the Lisp language. This list looks like this is exactly the same as this list looks like this. Both examples show what to Lisp is the same list. The list made up of the symbols this list looks like and this, in that order. So whatever the white space is, it doesn't care, as long as there's white space. Extra white space and new lines are designed to make a list more readable by humans. When Lisp reads the expression, it gets rid of all the extra white space, but it needs to have at least one space between atoms in order to tell them apart. Odd as it seems, the examples we have seen cover almost all of what Lisp lists look like. Every other list in Lisp looks more or less like one of these examples, except that the list may be longer and more complex. In brief, a list is between parentheses, a string is between quotation marks, a symbol looks like a word, and a number looks like a number. For certain situations, square brackets, dots, and a few other special characters may be used, however we would go quite far without them. Okay. GNU Emacs helps you type lists. When you type a Lisp expression in GNU Emacs, using either Lisp interaction mode or Emacs Lisp mode, you have available to you several commands to format the Lisp expression so it is easy to read. For example, pressing the Tab key automatically indents the line the cursor is on by the right amount. A command to properly indent the code in a region is customarily bound to meta control \. Indentation is designed so that you can see which elements of a list belong to which list elements of a sublist. See which elements of a list belong to which list. Elements of a sublist are indented more than the elements of the enclosing list. In addition, when you type a closing parenthesis, Emacs momentarily jumps the cursor back to the matching opening parenthesis so you can see which one it is. This is very useful since every list you type in Lisp must have its closing parenthesis match its opening parenthesis. See major modes, blah blah blah. Okay. Run a program. Whew. A list in Lisp, any Lisp, is a program ready to run. If you run it, for which the Lisp jargon is evaluate, the computer will do one of three things. Do nothing, except return to you the list itself, send you an error message, or treat the first symbol in the list as a command to do something. Usually, of course, it is the last of these three things that you really want. So let's just read that again because I zoned out. A list in Lisp, any Lisp, is a program ready to run. If you run it, for which the Lisp jargon is evaluate, the computer will do one of three things. Do nothing except return to you the list itself, send you an error message, or treat the first symbol in the list as a command to do something. Let's test that out. So I'm going to evaluate an expression. I'm just going to put hello world and I am an atom in our list in my mode line. Let me evaluate. Okay, so it just said invalid function. So yeah, that's interesting. So it didn't return the list to me. I guess it sent me an error message, but I was sort of expecting it to just spit out true or spit out the list, but instead it's gone invalid function. So that's kind of unexpected. Anyway, the single apostrophe that I put in front of some of the example lists in preceding section is called a quote. When it precedes a list, it tells Lisp to do nothing with the list other than take it as it is written. But if there is no quote preceding a list, the first item of the list is special. It is okay. So yeah, mystery solved. So let's try that again. So hello world, I am an atom in our list. Let's try that. Okay, and then that returned the list. Interesting. Okay. In Lisp, these commands are called functions. The list plus 2 shown above did not have a quote in front of it, so Lisp understands that the plus is an instruction to do something with the rest of the list. Add the numbers that follow. Okay, so let's try that out now. So I'm going to do plus 2, and that gave me 4. That's what I expected. Now I'm going to do quote plus 2, and I expect to get back plus 2, a list. Yep, and that's what I got. Okay, cool. Okay, so let me just quickly write that down. So the single apostrophe before a list causes that list to return. Without the single apostrophe, the first element of the list will be treated as a command. And I'm going to do visual line mode because I'm not completely autistic, although I am using Emacs. So alright, so if you are reading this inside of GNU Emacs in info, here's how you can evaluate such a list. Place your cursor immediately after the right hand parentheses of the following list and type Control X, Control E. So Control X, Control E. I'm gonna just evaluate it. That's kind of cool. So what it did there was I just put my cursor after the expression and hit that shortcut and evaluated the code for that line, I guess. You'll see the number 4 appear in the echo area. What you have just done is evaluate the list. The echo area is the line at the bottom of the screen that displays or echoes text. Now try the same thing with a quoted list. Place the cursor right after the following list and type Control X, Control E. So I'm just gonna go directly there and then Control X, Control E. This is a quoted list. Yeah, cool. You'll see this is a quoted list appear in the echo area. I did indeed. In both cases, what you are doing is giving a command to the program inside of GNU Emacs called the Lisp interpreter, giving the interpreter a command to evaluate the expression. The name of the Lisp interpreter comes from the word for the task done by a human who comes up with the meaning of an expression, who interprets it. Okay, yep, seems a little bit obvious, but okay. You can also evaluate an atom that is not part of a list, one that is not surrounded by parentheses. Again, the Lisp interpreter translates from the human readable expression to the language of the computer. But before discussing the C variables, we will discuss what the Lisp interpreter does when you make an error. Okay, footnotes. Emacs shows integer values in decimal, in octal, and in hex, and also as a character. But let's ignore this convenience feature for now. So I don't know if you guys could see it, but when I evaluated that expression, 2 plus 2, it did $?C hyphen D. Apparently it's a character. I'm not quite sure what that means. Okay. Anyway, generate an error message. Partly so you don't worry if you do it accidentally. We will now give a command to the Lisp interpreter that generates an error message. This is a harmless activity, and indeed we will often try to generate error messages intentionally. Once you understand the jargon, error messages can be informative. Instead of being called error messages, they should be called help messages. They're like signposts to a traveler in a strange country. Deciphering them can be hard, but once understood, they can point the way. How long have I been streaming anyway? About half an hour on this one. So I might go another half hour and then move on to something else. I'm not sure if there's anything else I wanted to do today, but we'll see. The error message is generated by a built-in GNU Emacs debugger. We will enter the debugger. You get out of the debugger by typing Q. What we will do is evaluate a list that is not quoted and does not have a meaningful command as its first element, so I'm way ahead of him already. I already made that mistake. Here is the list, almost exactly the same as the one we just used, but without the single quote in front of it. Position the cursor right after it and type Control X, Control E. No. Control X, Control E. And we got a Lisp error. Void function this. This is an unquoted list. Eval, this is an unquoted list. Nil. Elisp eval last S expression. Eval last X expression. Fun call interactively. Blah 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 blah. Backtrace window will open up and you should see the following in it. Your cursor will be in this window. You may have to wait a few seconds before it becomes visible to quit the debugger and make the debugger. I love how that's cut off. Thankfully I already know it, how to do it. Oops. Oops. Okay, so apparently the negative argument to Wow, I just got a message saying properties for sale in these regions. What the fuck is that? I'm gonna block that number. Yes. Okay. Alright. Quit the debugger and make the debugger window go away. Type Q. Please type Q right now so you become confident that you can get out of the debugger. Then type Control X, Control E again to re-enter it. Based on what we already know, we can almost read this error message. Let's see, it's a bit annoying. I'll just enter it manually. I'll just make an error manually. There we go. See, that's an invalid function. It's not quite the same thing, is it? This is our list. That'll give us something that's equivalent. Alright, yeah, void function. Based on what we already know, we can almost read this error message. You read the backtrace buffer from the bottom up. It tells you what Emacs did. When you typed Control X, Control E, you made an interactive call to the command eval last special expression. Eval is an abbreviation for evaluate, and S expression is an evaluate for symbolic expression. Oh, symbolic expression. I got the lingo wrong. The command means evaluate last symbolic expression, which is the expression just before your cursor. Each line above tells you what the Lisp interpreter evaluated next. The most recent action is at the top. The buffer is called the backtrace buffer because it enables you to track Emacs backwards. At the top of the backtrace buffer, you see the line debugger entered Lisp error void function this. So command X. Oh yeah, okay. So first we did command execute eval expression, then we did call interactively eval expression nil nil. Then we did fun call interactively eval expression. This is a list nil nil 127. Then that led to eval expression. This is a list nil nil 127. Then eval. This is a list nil. This is a list, and then debugger entered. Yeah, okay. The Lisp interpreter tried to evaluate the first atom of the list, the word this. It is this action that generated the error message, void function this. The message contains the word void function and this. The word function was mentioned once before. It is a very important word. For our purposes, we can define it by saying that a function is a set of instructions to the computer that tell the computer to do something. Now we can begin to understand the error message, void function this. The function, that is the word this, does not have a definition of any set of instructions for the computer to carry out. A slightly odd word void function is designed to cover the way Emacs Lisp is implemented, which is that when a symbol does not have a function definition attached to it, the place that should contain the instructions is void. On the other hand, since we were able to add 2 plus 2 successfully by evaluating plus 2, 2, we can infer that the symbol plus must have a set of instructions for the computer to obey, and those instructions must be to add the numbers that follow the plus. It is possible to prevent Emacs entering the debugger in cases like this. We do not explain how to do that here, but we will mention that the result looks like, because you may encounter a similar situation if there is a bug in some Emacs code that you are using. In such cases, you will see only one line of error message. It will appear in the echo area and look something like this. Symbol's function definition is void. This. Okay. The message goes away as soon as you type a key, even just to move the cursor. We know the meaning of the word symbol. It refers to the first atom of the list. The word this, the word function refers to the instructions that tell the computer what to do. Technically the symbol tells the computer where to find the instructions, but this is a complication we can ignore for the moment. The error message can be understood. Symbol's function definition is void. The symbol, that is the word this, lacks instructions for the computer to carry out. Okay. Oh. Yeah. I'm just going to fix up the titles for these videos. It'll be 2.1. Oops. 2.1. And then I think I can just get rid of that 2-minute video. I don't think I said anything particularly interesting in it. And then I'm gonna rename this one to 2.2. Alright, we can articulate another characteristic of Lisp based on what we have discussed so far. An important characteristic, a symbol like plus is not itself the set of instructions for the computer to carry out. Instead, the symbol is used, perhaps temporarily, as a way of locating the definition or set of instructions. What we see is the name through which the instructions can be found. Okay, so names of people work the same way. I can be referring to you as Bob, however, I am not the letters B-O-B, but am or was the consciousness consistently associated with a particular life form. The name is not me, but it can be used to refer to me. In Lisp, one set of instructions can be attached to several names. For example, the computer instructions for adding numbers can be linked to the symbol plus as well as to the symbol plus, and are in some dialects of Lisp. Among humans, I can be referred to as Robert as well as Bob, and by other words as well. On the other hand, a symbol can have only one function definition attached to it at a time. Otherwise, the computer would be confused as to which definition to use. If this were the case among people, only one person in the world could be named Bob. However, the function definition to which the name refers can be changed readily. The function definition to which the name refers can be changed readily. Interesting. It sounds mutable. I don't know. Since Emacs Lisp is large, it is customary to name symbols in a way that identifies the part of Emacs to which the function belongs. Thus, all the names for functions that deal with text info start with text info, and those for functions that deal with reading mail start with rmail. Oh, I don't know about you guys, but I'm getting pretty tired. It's pretty dry. Drink some more V, I guess. Based on what we have seen, we can now start to figure out what the Lisp interpreter does when we command it to evaluate a list. First, it looks to see... What's the time? Shit, it's 7 o'clock already. First, it looks to see whether there is a quote before the list. If there is, the interpreter just gives us the list. On the other hand, if there is no quote, the interpreter looks at the first element in the list and sees whether it has a function definition. If it does, the interpreter carries out the instructions in the function definition. Otherwise, the interpreter prints an error message. This is how Lisp works. Simple. There are added complications which we will get to in a minute, but these are the fundamentals. Of course, to write Lisp programs, you need to know how to write function definitions and attach them to names, and how to do this without confusing either yourself or the computer. Complications. Alright, now for the first complication. In addition to lists, the Lisp interpreter can evaluate a symbol that is not quoted and does not have parentheses around it. The Lisp interpreter will attempt to determine the symbol's value as a variable. This situation is described in the section on variable. The second complication occurs because some functions are unusual and do not work in the usual manner. Those that don't are called special forms. They are used for special jobs like defining a function, and there are not many of them. In the next few chapters you will be introduced to several of the more important special forms. As well as special forms, there are also macros. A macro is a construct defined in Lisp, which differs from a function in that it translates a Lisp expression into another expression that is to be evaluated in place of the original expression. A macro is a construct defined in Lisp which differs from a function in that it translates a Lisp expression into another expression that is to be evaluated in place of the original expression. For the purposes of this introduction, you do not need to worry too much about whether something is a special form, macro, or ordinary function. For example, if is a special form. Oh, okay, I see what they mean by special form. But when is a macro? Oh, okay. That's a bit more interesting. In earlier versions of Emacs, defun was a special form, but now it is a macro. Okay, still behaves in the same way. The final complication is this: if the function that the Lisp interpreter is looking at is not a special form, and if it is part of a list, the Lisp interpreter looks to see whether the list has a list inside of it. If there is an inner list, the Lisp interpreter first figures out what it should do with the inside list, and then it works on the outside list. If there is yet another list embedded inside the inner list, it works on that one first, and so on. It always works on the innermost list first. The interpreter works on the innermost list first to evaluate the result of that list. The result may be used by the enclosing expression, so that makes perfect sense. So, it's like when you're doing maths, if you need to figure out 5 times 6 divided by 7, and 6 divided by 7 is in brackets, you obviously need to do 6 divided by 7 first before you can do the multiplication step. Otherwise, the interpreter works left to right from one expression to the next. So that's, yeah. Okay, byte compiling. One other aspect of interpreting. The Lisp interpreter is able to interpret 2 kinds of entity: humanly readable code, on which we will focus exclusively, and specially processed code called byte compiled code, which is not human readable. Byte compiled code runs faster than humanly readable code. You can transform humanly readable code into byte compiled code by running one of the compile commands such as byte compile file. Byte compiled code is usually stored in a file that ends with a ELC extension rather than an EL extension. You will see both kinds of file in the Emacs Lisp directory. The files to read are those with EL extensions. As a practical matter, for most things you might do to customize or extend Emacs, you do not need to byte compile, and I will not discuss the topic here. See byte compilation eLisp for a full description of byte compilation. Alright, evaluation. We're almost there. 15 minutes to go. When the Lisp interpreter works on an expression, the term for the activity is called evaluation. We say that the interpreter evaluates the expression. I've used this term several times before. The word comes from its use in everyday language: to ascertain the value or amount of to appraise, according to Webster's New Collegiate Dictionary. Okay. So how the Lisp interpreter acts. After evaluating an expression, the Lisp interpreter will most likely return the value that the computer produces by carrying out the instructions it found in the function definition, or perhaps it will give up on that function and produce an error message. The interpreter may also find itself tossed, so to speak, to a different function, or it may attempt to repeat continually what it is doing forever and ever in an infinite loop. These actions are less common and we can ignore them. Most frequently, the interpreter returns a value. At the same time, the interpreter returns a value. It may do something else as well, such as move a cursor or copy a file. This other kind of action is called a side effect. Actions that we humans think are important, such as printing results, are often side effects to the Lisp interpreter. It's fairly easy to learn to use side effects. In summary, evaluating a symbolic expression most commonly causes the Lisp interpreter to return a value and perhaps carry out a side effect or else produce an error. Okay, evaluating in lists. If evaluation applies to a list that is inside another list, and the outer list may use the value returned by the first evaluation as information when the outer list is evaluated, this explains why inner expressions are evaluated first. Yeah, so this is what I was talking about before. The values they return are used by the outer expressions. So like I said, they've got a maths example here. So we can investigate this process by evaluating another addition example. Place your cursor after the following expression. So, the number 8 will appear in the echo area. What happens is that the Lisp interpreter first evaluates the inner expression plus 3, for which the value 6 is returned. Then it evaluates the outer expression as if it were written plus 2, 6, which returns the value 8. Since there are no more enclosing expressions to evaluate, the interpreter prints the value in the echo area. Now it is easy to understand the name of the command invoked by the keystrokes Control X, Control E. The name is eval last symbolic expression. The letters SEXP are an abbreviation for a symbolic expression, and eval is an abbreviation for evaluate. The command evaluates the last symbolic expression. As an experiment, you can try evaluating the expression by putting the cursor at the beginning of the next line immediately following the expression, or inside the expression. Here is another copy of the expression. As an experiment, you can try evaluating the expression by putting the cursor at the beginning of the next line immediately. Okay. So that give me 8. What if I go inside? That gave me 6. Yeah, okay. Interesting. So I can actually evaluate things inside an expression. That's super interesting. So I wonder, what if I do so if I evaluate this 8 and then I go 1 back and evaluate 6, and then if I go 1 back and evaluate it's 4, and then if I go 1 back and evaluate it's 2, and then if I go 1 back and evaluate it's also 2. That's interesting. 2. 2. Interesting. Oh, that didn't work either. That's kind of weird. Okay. So, does that evaluate to 2? Yes. And then this also evaluates to 2? Oh, that's very strange. I don't quite understand what's happening there. it, right? What the fuck? What's the problem? Oh, okay, weird. Anyway. Okay. If you place the cursor at the beginning of the blank line that immediately follows the expression and type Ctrl+X, Ctrl+E, you will still get the value 8 printed in the echo area. Now try putting the cursor inside the expression. If you put it right after the next to last parenthesis, so it appears to sit on top of the last parenthesis, you will get a 6 printed in the echo area. This is because the command evaluates the expression +3, 3. Now put the cursor immediately after a number, and you will get the number itself. Okay. So that's solved that. In Lisp, if you evaluate a number, you get the number itself. This is how numbers differ from symbols. If you evaluate, So placing the cursor directly next to a number will evaluate that number. This differs from symbols and is one of the special properties that distinguish numbers. Okay, so there we go, we've figured that out. You will get a value returned that is the result of the computer carrying out the instructions in the function definition attached to that name. If a symbol by itself is evaluated, something different happens, as we will see in the next section. Okay. Wonder what does happen. Let's try it now. So that's to be expected. So I'll add a quote, and that returns this. But if I put my cursor right after it, okay. Rightio. What if I make it a string? Okay, so then that just returns a string. Okay. In Emacs Lisp, a symbol can have a value attached to it just as it can have a function definition attached to it. The two are different. The function definition is a set of instructions that a computer will obey. A value, on the other hand, is something such as a number or a name that can vary, which is why such a symbol is called a variable. The value of a symbol can be any expression in Lisp, such as a symbol, number, list, or string. A symbol that has a value is often called a variable. A symbol can have both a function definition and a value attached to it at the same time. Okay. That's weird. So I think as questions come up, I'm just gonna create to-dos for me to investigate. That way when they come up, my questions will sort of still be in my head. I'll be thinking about it, rather than just kind of thinking, oh, that's weird, what do they mean by that, and then moving on. I feel like if I just note down what questions I have as I'm reading, I'll kind of I'll kind of stay more actively engaged with the content. So where was I? Or it can have just one or the other. The two are separate. This is somewhat similar to the way the name Cambridge can refer to the city in Massachusetts and have some information attached to the name as well, such as Great Programming Center. Didn't quite understand that analogy. Another way to think about this is to imagine a symbol as being a chest of drawers. The function definition is put in one drawer, the value in another, and so on. What is put in the drawer holding the value can be changed without affecting the contents of the drawer holding the function definition, and vice versa. Okay. I still don't quite understand. Fill column, an example variable. The variable fill column illustrates a symbol with a value attached to it. In every GNU Emacs buffer, this symbol is set to some value, usually 72 or 70, but sometimes to some other value. To find the value of this symbol, evaluate it by itself. If you are reading this in info inside of GNU Emacs, you can do this by putting the cursor after the symbol and typing, okay, so. Whoops. 70, okay. After I typed Control X, Control E, Emacs printed the number 72 in my echo area. This is the value for which fill column is set for me as I write this. It may be different for you in your info buffer. Notice that the value returned as a variable is printed in exactly the same way as the value returned by a function carrying out its instructions. From the point of view of the Lisp interpreter, a value returned is a value returned. What kind of expression it came from ceases to matter once the value is known. Okay. A symbol can have any value attached to it, or to use the jargon, we can bind the variable to a value, to a number, such as 72, to a string, such as this, to a list, such as list of spruce, pine, and oak. We can even bind a variable to a function definition. That makes sense to me. I can't figure out how it can simultaneously have a value and a function definition, though. A symbol can be bound to a value in several ways. See setting the value of a variable for information about one way to do this. Okay, so it's not really telling me the answer to that question. So I think either I'm going to have to look that up separately or it'll come back up later. So I'm just going to leave it for now and move on. Error message for a symbol without a function. When we evaluated fill column to find its value as a variable, we did not place parentheses around the word. This is because we did not intend to use it as a function name. Okay. If fill column were the first or only element of a list, the Lisp interpreter would attempt to find the function definition attached to it. But fill column has no function definition. Try eval. Okay. Yeah, I'm starting maybe a little bit kind of understanding this. So maybe if it's the first element in a list, then that calls a function associated with that symbol. But if it were the second item in a list, then it just calls the value. Maybe that's how it works. So maybe like I could have a value associated with fill column, and if I put fill column somewhere in a list besides the first element, then that value gets called. But if I put it at the start of the list, it calls the function. Okay, I think I sort of get it. You will create a bug. So it's gonna create another error like we saw before. Remember to quit the debugger and make the debugger window go away. Error message for a symbol without a value. If you attempt to evaluate a symbol that does not have a value bound to it, you will receive an error message. You can see this by experimenting with our 2+2 addition. In the following expression, put your cursor right after the plus. Okay. Void variable. Why is it void? I'm a little confused why it's void when there's a function associated with it. Why doesn't it just run the function? In GNU Emacs 22 you will create a, so I'm gonna sort of add my thoughts up until now. So when a symbol is evaluated in isolation or as a non-leading, I guess would be the adjective, or as a non-leading element in a list, Emacs Lisp expects a value. When called, I don't know if that's quite the right verb, but when called as the leading element in list, Emacs will attempt to evaluate a function associated with that symbol. Okay. So I'm going to take a quick toilet break. Looks like I had somebody watching for like 5 minutes. Sorry I didn't notice you earlier, I just saw you disappearing. So yeah, I'm gonna take a quick toilet break and then I'll be right back. Okay, so it's about 7:30 now. Actually, I was gonna say I would stop at 7:30, since I've already breached the hour mark. So you know it's slow going, but part of what I want to do with this channel is to show the nitty gritty, and sometimes the nitty gritty is really boring or really slow. Eventually I'm going to create some edited content, but at the moment it's just going to be these live streams just to motivate me to keep pushing forward with this stuff. You know, it's weird when I'm doing this stuff, with the live stream going, I feel sort of like I got company. And when I noticed actually that somebody was watching, it was a little strange, because it was sort of like I went from this state of mind where I felt like I had company to this state of mind where I really felt like I had company, and that was a little interesting. So hopefully I notice quicker next time and I can interact with that person, because you know it gets kind of lonely in here. But I'm having fun, just sort of talking to myself at the moment. Yeah, this is fine the way it is. But my throat's starting to get sore now, so I'm going to end the stream here and pick it up. Maybe not tomorrow. Tomorrow I'll stream my language learning again, but probably won't have time to do this until maybe Thursday. What's the date today? It's the 3rd. So after this I'm going to maybe stream some more Chinese study. I use another program for Chinese study. The only problem is I'm not 100% sure whether it would be okay for me to stream that content or not. So I'm not 100% sure what I'm going to do with that. Maybe I won't stream it yet. Maybe I'll send them an email and just see if it's okay for me to stream my studying. Anyway, to all those who are not watching at the moment, but maybe you're watching in the future when this channel is really big and I have lots of well-produced content for it, thanks for sticking around if you made it this far. I know I'm not that interesting to watch. Hopefully as people come in I can interact with them, and then that will create some more interesting interactions. Anyway, I'm going to sign off here, and I hope you guys have a lovely evening or morning depending on if you're watching the replay. So, good night.